Hello, dependency inversion principle, naive but waterfall principle. High-level components should not depend on low-level components. Both should depend upon abstractions. Abstractions should not depend upon details or relationships in a program must terminate at an abstract class or interface. Traditional functional programming, high-level components, business application rules, low-level components, implementation of the business rules. High-level components complete their functionality by calling invoking the low-level implementation provided by the low-level components. High-level depends on the lower level. What are the implications? Dependency is transitive. Change in the lower level modules can have direct effects on the higher level modules. Reuse, we should be able to reuse the high level policy setting modules. Conclusions, strive for having higher level modules be independent of the lower level modules. The IP is at the heart of framework design. Inversion of ownership. Each high-level module declares an abstract interface for the services it needs. Lower-level layers are realized using through the abstract interface. Here, upper-level layers don't depend on the lower-level modules. Lower layers depend on the abstract service layers declared in the upper layers. VIP example dependency inversion principle can be applied whenever one class sends a message to another. Consider the case of a button and lamp object. A button, since the external environment receives poll message, determines whether or not the user has passed it. Lamp affects the external environment or receiving turn on message. Why is the design naive? The dependency between lamp and button implies that lamp cannot be modified without changing, at least complete. Also, not possible to reuse the button class to control a motor portal object. The button and lamp code violates the IP. Adding more abstraction if there can be multiple types of buttons of the switching uh, device. Abstraction can use to further refine the design. Conforming code. One of the most common places that designs depend upon concrete classes is when those designs create instances. By definition, you cannot create instances of abstraction classes. Thus, to create instances, you must depend on concrete classes. Interface segregation principle. When we design an application, we should take care how we are going to make abstract a module which contains several submodules. The module implemented by a class, we can have an abstraction of the system done in an interface. Having an interface solution is not a good solution and may induce inappropriate behavior in the system. The interface segregation principle states that clients should not be forced to implement interfaces they don't use. Instead of one fat interface, many small interfaces are preferred based on groups of methods, each one serving one submodule. Clients should not be forced to depend upon interfaces that they don't use. ISV example. Below is an example which violates the interface segregation principle. We have a manager class which represents a person which manages the workers. And we have two types of workers, some average and some very efficient worker. This is why in this case the iWorker is considered a polluted interface. If we keep the present design, the new robot class is forced to implement the eighth method. Principle of least knowledge. One very important yet often overlooked design guideline which I advocate is the principle of least knowledge, also as known as the law of Demeter, or more precisely, the law of Demeter for functions methods, is a design principle which provides guidelines for designing a system with minimal dependencies. It is typically summarized as only talk to your immediate friends. Code example, consider the following. We have three classes. Class A has an instance member of type class B. Class B has an instance member of type class C. The above example is quite common, however, it violates the principle of least knowledge as it creates multiple dependencies, thus reducing maintainability, as should the internal structure of a class A need to change, so would all instances of A. Principle of loose coupling. In computing and systems design, a loosely coupled system is one in which each of its components has or makes use of little or no knowledge of the definitions of other separate components. Coupling refers to the degree of direct knowledge that one class has the another. Strong coupling occurs when a dependent class contains a pointer directly to a concrete class which provides the required behavior. The dependency cannot be substituted or its signature changed without requiring a change to the dependent class. Code example. Thank you.